Okay, welcome back to Pre-Calculus, Module 1, Lesson 17. We are going to be going, we already covered exercises 1 to 9. Now we're going to cover exercises 10 to 13. Well, Exploratory Challenge 2 and exercises 10 to 13. Okay, so illustrate algebraically and geometrically. So we're going to have some operations, geometric transformations, and we're going to try and show examples of them. So right off the bat, actually, let's just go ahead and find out modulus of z. We're just going to set ourselves up so it'll be much easier later on. An argument of z. So modulus z will be 3 squared. So modulus z is going to be 3 squared plus 3 squared. And again, you see I'm not really using the negative because when I square it, it's going to be positive anyway, so that's fine. Equals 9 plus 9, so 18. And that one will be, so 3, 6, 3, 2. So 3 root 2. So 3 root 2. And the argument, well, that's going to be the inverse tangent, but I can actually see that I just have this and this are the same number. So since these two numbers are the exact same, I know I'm going to have a 45-45 triangle. And we can see that just real quick. If I go 1, 2, 3, 1, 2, 3, and if I'm right there, I know it evenly splits this quadrant, so that's going to be 45 degrees. Okay, so that will be, but it'll be 45 degrees in quadrant 4, so that'll be the same thing as 315 degrees, but let's go with radians. So that would be, so 45 is pi over 4. So 315 would be equal to 7 pi over 4. So 7 pi over 4. And let's find modulus of w. That's very easy because it's just directly on an axis. So I know that it'll just be that distance. And argument of w will be equal to, well, -2 is right there. So this rotation would be 270 degrees, or also just 3 pi over 2. 3 pi over 2. So now let's actually get into it. Addition, z plus w. Ooh, first of all, let's go ahead and erase this guy over here. There we go. Z plus w. What is the geometric transformation? Well, if we were to call, whenever we were doing just addition and subtraction, I'm just going to take z plus w and just translate z by w. So that'd be just 3 minus 3i plus, and that'd be plus -2i. That one will be 3 minus 5i. So I would go from 1, 2, 3, 1, 2, 3 there. And this is going to be z. And then this is w. So then I'm just going to take, whoop, that's not w. This is w. So I'm going to take this, which is a distance of 2, and I'm going to move it down to, well, that's supposed to be right there at the 3. Okay, not drawn to scale, but you get the point. And this is z plus w. So this new point, this is a 2, by the way. Oh, by the way, for many cases, so we don't get confused, sometimes I write my 2's like this, sometimes I write them like this, but this will always be z. I will always have a line through that. So if you see something that looks a little bit like this, just know that that will be a 2. Okay. All right, next one, subtraction. Well, this is going to be pretty much the exact same. I'm going to take translate z by w. It's just going to be a standard translation. Also, my palm kind of draws things on the screen sometimes, and I don't realize it. 3 minus 3i minus 2i. That one will give me 3 minus I. So that one will, again, take me 1, 2, 3, 1, 2, 3. Right there. That will be z. This will be w. And again, that's just a distance of 2. So I'm just going to move up 2. And then this one will be Z minus W. Again, that's just a distance of 2. So the conjugate of Z. So the conjugate of Z, remember, if Z equals A plus BI, the conjugate will be A minus BI. So now that we have Z equals 3 minus 3I. So Z bar, the conjugate, will be 3 plus 3I. And then that, if I draw this, 1, 2, 3, 1, 2, 3, right there, 1, 2, 3, right there. Again, I know not drawn to scale, but 3, 3. So it really just Z bar, it really just reflects me across my real axis. So reflect Z across real axis. Real axis. There we go. Okay, next one, multiplication. Z or W times Z. So this is what we've really been doing lately. So I'm just going to do what we already know. And then that means that W times Z, I'm taking W and I'm rotating it. So Z, let's write this out fully. Rotation of Z by arg W and scaled by modulus W. Whoops. Modulus W. There we go. So let's come up here again. Remember Z, the absolute, or modulus Z equals 3 root 2 and arg Z equals 7 pi over 4. So let's do that. So I know that, I learned this, I believe, in lesson 15, equals W times Z. So the modulus of the product, that's what this is right here, the modulus of the product of two complex numbers is equivalent to the product of the moduli. And the argument, W times Z, the argument, oh, that's not a Z. There we go. Arg WZ is the sum of the arguments. So arg W plus arg Z. So again, I know that modulus Z equals, I believe it was 4. What was it? No, 3 root 2. Where is this? There we go. There we go. Okay. 3 root 2 and arg Z equals, short-term memory, 7 pi over 4. 7 pi over 4. And modulus W equals 2 arg W equals 3 pi over 2. So let's put those together. I'm going to go ahead and I'm going to do it on the side over here so I can leave some room for, I'll just graph it on the side. Okay. So modulus of WZ equals 3 root 2 times 2. So that will be 6 root 2. And then arg WZ is equal to 7 pi over 4 plus 3 pi over 2. 3 pi over 2. That will be 7 pi over 4 plus 6 pi over 4. That will give me 13 pi over 4. But remember, I have to stay between 0 and 2 pi. So this 13 pi over 4 is the same thing as, well, that's 13 minus 8. That will be 5 pi over 4, putting me just into quadrant 3. Okay. And let's go ahead and take this 6 root 2. Let's just put it in a rectangular form. 6 root 2 cosine of 5 pi over 4 plus I sine of 5 pi over 4. And then this is going to be equivalent to 6 root 2 of, okay, this is still just pi over 4, just in the third quadrant. So x is going to be negative, so negative root 2 over 2. Oops, don't need that. Come on, go away. There we go. And then sine will also be my y, which will also be negative there, so minus root 2 over 2. And then so this is going to be equivalent to 6, whoops, I need to get back to my, there we go. Is going to be equivalent to 6, oh, let me change that as well. Let me go ahead and erase this. The equivalent to negative 6 minus 6i. And then from there, let's go ahead and just graph this. I know it's a little bit over here on the side, but we can make do. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then that will be right over there. Bada bing, bada boom. That one will be the W, and the other one will be the Z. 1, 2, 3. 1, 2, 3. Ooh, that is so not accurate. There we go. So once I take that, multiply by that, I can come over here. Okay. The reciprocal of Z. So remember, reciprocal means 1 over. Okay, so this is going to have, and this is also what we've been kind of working on today in this lesson as well. So this is going to rotate a real number, the real number 1, the opposite. It's going to rotate the opposite direction. Opposite. Rotation of Z, and it's going to scale by, the reciprocal of the modulus of Z. So it's going to scale by the reciprocal of the modulus of Z. So it's basically going to rotate by negative arg Z, and it's going to scale by 1 over modulus Z. And again, be careful with this just because we really want to have it be between 0 and 360 or 0 and 2 pi. Okay. Let's go ahead and do some math on that one. Though. Let's show it out. So if I take my 3 minus 3i, and that is a rotation of, so it has a rotation of 7 pi over 4, and it has a dilation, so r mod z equals the 3 root 2. So I want to find a rotation to get back to the real number 1. Okay, so if z is 3 root 2, I want to scale by 1 over 3 root 2. I want to rotate by basically negative 7 pi over 4, right? So if I want to scale by this amount and rotate by this amount, let's first put this one in terms of 0 to 2 pi. That will be the same thing as pi over 4. So the argument of the reciprocal would be pi over 4, this number right here. And this would be, so 1 over 3 root 2, top and the bottom by root 2, so that'd be root 2 over 6. So I have it right there. That's all I need. So that would be root 2 over 6, and that would be cosine over 4 plus I sine of pi over 4. And that one will equal root 2 over 6 times root 2 over 2 plus root 2 over pi. So again, I'm just going to have 2's on the top. That's going to cancel the 2's. This 6 plus I. And with obviously arg z being, or arg z bar, or not arg z bar, the argument of this number is our pi over 4, and the modulus is the root 2 over 6. So then this number will be in the first quadrant and will look like, if this is 1 and this is 1, then it's really just like right there, 1/6 of the way. Where this, yeah, let's just go keep it there. We understand that the, where is it? The W is down here. Actually, let's right here. Okay. So last one, division, W over Z. And this variant, we're just basically going to be putting together these two ideas. We're rotate, it's going to rotate by rotating W by 2 pi minus arg Z, followed by a rotation, or followed by a scaling, and so scaled by 1 over modulus Z. So it is just like this one right here, except we're just affecting it by some complex number W. So again, just like in the previous ones, we have the exact same thing. In fact, I'm just going to go ahead and bring it on down. So I have W being negative 2I, Z equals, let me go ahead and erase this. There we go. Z equals 3 minus 3I. 1 over Z equals 1 over 6 plus 1 over 6. Nope, that didn't really right there. So minus, oops. And this is going to be, ooh, my pen is not working. There we go. Minus 1 over 6I. And then so I'm just going to go ahead and multiply. So W over Z is the same thing as W times 1 over Z. So that's just going to be negative 2I times 1 over 6 minus 1 over 6I. Give me, so I'm going to multiply negative 2I by 1 over 6. That's going to be negative 1/3 I. And the negative 2I times negative 1 over 6I is going to be positive. Oh, you know what? I am completely silly. That is a positive 1 over 6. Positive 1 over 6 right there. My bad. So the negative 1/3 I, and that will be plus third, A plus BI, 1/3 minus 1/3 But let's go ahead and do it the long way as well, just so we can see this. D equals negative 2i over 3 minus 3i. In order to go ahead and get that out of the fraction form, let's do 3i. I'm going to multiply the top and the bottom by 3 plus 3i, 3 plus 3i. That one will equal negative 6i, so negative 6i minus 6i squared. And this one will obviously equal 9. I know my minus 9 squared. I can already see where this is going. This is going to be 6 minus 6i over 9 minus, whoop, did I forget something there? No, I don't think so. I'm just being silly. That's going to become, there we go, that's positive. I thought we were going to go to 0 for a second. I was scared. Okay, let's just go ahead and take a 3 out of everything. So this is just 2 minus I over, and that one would be 18, and then 18 divided by, actually, you know what, let's just go ahead and take a 6 out of everything instead. There we go. And we're going to get 1 I over 3, which will give us our 1 over 3 minus 1 over 3i. And I keep on having all of these little guys come up from my, there we go. Oh, much better. Okay, so we can see that by using our reciprocal of z, we arrive at the same exact answer. So by using this part, the math for this part, using this top one right here, we arrive at the same exact conclusion as we do doing all of our algebra. So, and we see that we're actually going to rotate back. Let's go ahead and graph this one part. So this is going to be equivalent to, and let's do a big graph right here. 1, 2, 3, 1, 2, 3. That one is Z, 1, 2, 3, 1, 2, 3, Z. This one is our W. And by doing 1 over Z, which remember, this was 1 over Z. If that's a 1 right there, our 1 over Z is like right there. So that'd be 1 over Z. Then we arrive at 1/3 minus 1/3 I. So about twice as far away, twice as far down, right there at our reciprocal. And that is the last exercise.